So halogenarenes, they are also named as haloarenes. And what we know about arene, when we say arene, it means the compounds which have a benzene ring in them. Okay, so haloarenes or halogenarenes are the compounds in which halogen atom is bonded to benzene. And halogen we know are fluorine, chlorine, bromine, iodine, and they are collectively called as X. Okay, so if we talk say haloarene, so we will write an X bonded to a benzene ring because X is a halogen, a general term, and its molecular formula will be C6H5X. If the benzene ring have, let's say, chlorine bonded to it, or benzene ring have a bromine bonded to it, then we are going to call it chlorobenzene or bromobenzene. Is this understandable to all of you?
Yes, sir.
So here it is.
Sir, what about iodine?
Iodobenzene.
Okay.
And in the same way, if fluorine is there, then fluorobenzene. Okay. How can we prepare these chloro or bromobenzene? How can we prepare these halobenzenes? Can anyone recall? No. We need a halogen, chlorine or bromine with benzene in the presence of a catalyst anhydrous AlCl3 or anhydrous AlBr3, right?
Yes.
So these can be prepared by electrophilic substitution of benzene with halogen in the presence of catalyst, and that catalyst is anhydrous AlCl3 or anhydrous AlBr3. Okay. So the reaction will be like this. A benzene molecule reacting with chlorine So a chlorine substitutes the hydrogen, forms chlorobenzene, and along with that, HCl is formed. And for this reaction, you are going we can use any catalyst, any one out of the two. One is anhydrous AlCl3 or one is anhydrous AlBr3. In the same way, if we have to make the bromobenzene, all the mechanisms we did in benzenes, right? So I'm not going to discuss the mechanisms again. So it reacts with forming bromobenzene and HBr. And here anhydrous AlBr3 is used. Okay. Is this clear? Walaikum assalam. Okay.
Yes.
Now, after this, we have a difference in reactivity of haloalkane and haloarene, or you can say halogenoalkane or halogenoarene. So, haloalkane, let's suppose I am taking a specific example, ethyl chloride, right? So here, in general, it's RCl, and R is a alkyl chain. And here, in halogenoarene or in haloarene, it's a benzene ring bonded with Cl. So in general, we write it ArCl. Ar refers to benzene ring. Okay. So this one is specifically called chloroethane, and this one is specifically called chlorobenzene. Okay. So in halobenzene, the carbon halogen, or we specifically talk about chlorobenzene, bond is more stronger than the carbon halogen bond in haloalkane or halogenoalkane. So it means if the bond is stronger in halobenzene, so halobenzene is going to be more reactive or less reactive? Less reactive. If the bond is stronger. Yeah. So it is because the orbital of chlorine having lone pair of electron
और इंटरव्यू एंट्री टेस्ट कंडक्ट करें अपने साथ ऑल ऑफ एडवर्स डॉक्यूमेंट
Yes, sir.
ओरिजिनल और उसकी फोटोकॉपी लाएं और की फोटोकॉपी
electron overlap slightly with the orbitals of carbon involved in pi bonding. If you want to see what will happen actually, so have a look over here. See, now assume here we have, instead of this hydrogen, we have a chlorine, and this chlorine have a 1p orbital as well, having a lone pair. So chlorine will overlap its this pair of this p orbital with this pi system in chlorobenzene. Is this understandable? Yes, Maham?
Yes.
Yes,
Yes,
Hassan,
sir.
did you understand? So, pi bonding system. So, the carbon halogen bond or carbon chlorine bond gets partial double bond character and act less reactive than halogenoalkane. Is this understandable?
Yes.
Okay. So, halogenoarenes do not undergo hydrolysis and other nucleophilic substitution reactions as readily as halogenoalkane. That the nucleophilic substitution of alkyl halide or halogenoalkane we have studied in AS, where chlorine is substituted by hydroxide or ammonia to form amine or CN to form nitrile. Okay, till here, is this clear to all of you? Yes, Maham, did you understand till here?
Yes, sir. Got it.
Okay. Now, so chlorobenzene, it means do not undergo nucleophilic substitution as easily, right? But chlorobenzene, then as it's a benzene, so it will undergo which substitution? Electrophilic substitution due to a benzene ring. Just give me a minute, please. Okay. So as we know, chlorine have a lone pair, right? Because it's in group 7, it's making one bond, so it have a 3 lone pairs with it. So chlorine atom bonded to benzene has a lone pairs of electrons. So chlorobenzene and we have seen that this is overlaps with the pi bonds. The lone pair of electrons of chlorine is localized into the ring, hence in chlorobenzene the electrophilic substitution occurs at 2, 4, and 6 positions. But chlorine is highly electronegative and it is not bonded to any other atom, so that's why chlorobenzene also becomes less reactive than benzene as well. Phenol and phenylamine are more reactive than benzene, but chlorobenzene is less reactive than benzene due to its higher electronegativity. So in chlorobenzene, this is carbon 1, this is 2, this is 3, this is 4, this is 5, this is 6. Or this one is 2, this one is 3, this one is 5, or this one is 6. So when the electrophilic substitution occurs, it occurs at these 3 positions, and you have to keep this in mind as well, that chlorobenzene is less reactive than benzene due to its high electronegativity. Yes, still here, is this clear to all of you? Yes, Maham. Yes, Hassan.
Yes, sir.
Okay. If you guys have any confusion till here, please ask. Okay. Then the next subtopic, that is the last topic of benzene, then we will move towards carboxylic acid derivatives in the next class. So next class we will have on Wednesday, and then on Sunday, on Friday, we will have extra class. And what time it was previously? 6 to 7, right? So this time we also have a class at 6 to 7 on Friday, an extra class. So here we have alkyl benzene. So what happens in alkyl benzene? Alkyl group is bonded to a benzene ring. So in general, a benzene ring bonded to an R chain or C6H5R. It's an alkyl benzene. Okay. Now, for example, if benzene ring is bonded to a CH3, then what will be its name? Yes.
Methyl benzene.
Or if it's bonded to CH2, CH3, which is also written as C2H5, so what will be its name in this? Yes. Methyl benzene, and this one is ethyl benzene. Is this clear? Okay. Now, how can we prepare methyl alkyl benzene? Yes, we did this reaction in benzene as well. On reacting benzene with alkyl halide, in the presence of catalyst, and we know the catalyst that is either anhydrous AlCl3 or anhydrous AlBr3. So here we have a benzene, and for example, if I have to make ethyl benzene, I will react it with chloroethane. So what will happen that the ethyl group from chloroethane substitutes the hydrogen and HCl is formed. So here the catalyst can be anhydrous AlCl3. Is this clear? Yes, ma'am, did you
Yes.
understand? Okay. Now
Yes,
there is a
sir.
small task for you guys. I'm writing the reactants and you guys have to make the product. Okay, make the product, Yusuf and sorry, Hassan and Maham, and you guys can WhatsApp me and I'm going to check yours. Anhydrous AlCl3. Yes, Maham and Hassan. If you guys are done, share it with me. आपने बना लिया? Strong. Almost. Close to this thing. Yes, this is correct. From here the chlorine is the bond and the benzene. Yes, Mohammed, Hassan, are you guys done? Yes.
Yes, sir. 1 minute.
Yes, please send me. Yes, Hassan, share it with me, please. Okay, I received both of yours. Let me check. There is a mistake in the product. Okay, Hassan, very good. See what mistake you did. The same mistake is done by Kubra as well. Okay, so see over here, if you see, the bond is broken from here, right? So this carbon is going to bond with the benzene. So the product have this organic structure. So what you were doing, Kubra, you were mixing both the atoms. So that is, you guys have to keep in mind whenever you are making the product, you will identify the bond which is broken. So see, this is the carbon whose bond is broken and from where the chloride is removed, and that chloride bonds with the hydrogen. So this carbon and this carbon will bond with each other. Yes, is this clear? Hmm?
Yeah.
Yes, Yusuf? No, with any carbon you can bond it. It's not necessary with the benzene right now. Okay. Now, after this, we have a reactions of alkyl benzene Okay. So we studied alkyl group in AS as well. What is the nature of alkyl group? Electron donating or electron withdrawing? Yes, can anyone recall? Alkyl group is electron donating in nature. See, that's what we have studied in AS for a carbocation. It gives the positive inductive effect. It induces the electron towards the positively charged carbocation to neutralize or to reduce its electron positive charge density. So it is always electron donating in nature. So if it's electron donating in nature, so it means when it is bonded to a benzene ring, it also provides electrons to the benzene ring. So due to this, the electron charge density on benzene ring bonded to an alkyl group increases. And if we know the bond, when the electron charge density increases, it specifically increases at 2, 4, and 6 positions, right? So hence, alkyl group, hence alkyl benzene will undergo electrophilic substitution at 2, 4, and 6 positions. That means if whether there is any other alkyl or a methyl, then the next substitution occur at these 3 positions only. Yes, is this understandable?
Yes.
Okay. Yes, Hassan. Yes, Yusuf and Kubra. Okay. Now, for example, I have a methyl benzene. If I react it with chlorine in the presence of anhydrous AlCl3, what will happen? I am going to get a mixture of the product like in some molecules chlorine substitutes the second, gets substituted on the second carbon, and in some molecules it gets substituted on 4th carbon. Is this clear to all of you?
Yes, sir.
And the byproduct over here will be HCl. Now, over here, for example, I am using the chlorine again, but now this chlorine is in the presence of UV rays and we boil benzene. Then what will happen? Yes. In this case, no substitution occur at a benzene ring, but the hydrogens of the alkyl chain get substituted, the free radical substitution reaction that we have studied in AS. So on depending upon the position condition, chlorine either substitute the hydrogen of the benzene ring or substitute the hydrogen of the side chain. Is this clear to all of you? Yes, Maha? Okay.
Yes.
Yes, Hassan? Okay. In the same way, if we have a methyl benzene and we react methyl benzene with concentrated nitric acid and for this reaction we use a catalyst concentrated sulfuric acid. So again we got the mixture of the product because some of the methyl benzenes the nitro group gets substituted at second carbon, and in rest of the groups, in rest of the molecules, it gets substituted at fourth. Is this clear?
Yes, sir.
No, it's a plus. Because see, we do not use, it's 1 mole, right? It's not 1 molecule. So if it's a 1 mole, then how many molecules of this is there? 6.02 exponent 23. So out of those, some will form this and some will form this. We always get a mixture of product in these cases. Okay. Now, after this reaction, we are left with the hydrogenation and the oxidation. So these are the two which we will continue in our next class, okay? Hydrogenation of alkyl benzene and then oxidation of alkyl benzene. That's what we are going to do in our next class. If you guys have any confusion till here, please ask. And then we are going to do the all the past papers related to these benzene structures. And we will, and just go over through, some of the AS reactions as well. But I'll try to make only that we will do these past papers for this benzene and their derivatives like phenyl benzene, alkyl benzene, phenol, phenylamine, and the benzene. Yes, Hassan, if you have any query, please ask. Yes, Maham?
No, sir.
Okay. Yes, Kubra? Okay, yes, Yusuf? Okay. So we will continue in our next class, okay? Take care, everyone.
Okay, sir. Allah Hafiz.
Allah Hafiz. Allah Hafiz, Hassan.